Imagine breathing on Mars. Sounds impossible, right? Not anymore. Welcome to the Martian miracle. Nestled inside NASA's Perseverance rover, a little experiment called MOXIE is making big waves. What's it doing, you ask? Quite simply, it's transforming Martian air into oxygen. Yes, the kind we humans need to survive. MOXIE, an acronym for Mars Oxygen In Situ Resource Utilization Experiment, has been hard at work since Perseverance touched down on Martian soil in 2021. With more than 16 runs under its belt, it has cranked out approximately 122 grams of oxygen. To help you visualize, that's enough breathable air to keep a small dog alive and kicking for 10 hours or a human for 4. Quite impressive, wouldn't you agree? Now, let's get a bit technical. MOXIE operates using a cutting-edge scientific process known as electrolysis. This process breaks down carbon dioxide, yes, the stuff we exhale, into carbon monoxide and oxygen ions. The carbon monoxide is discarded, and the oxygen ions bond together to form good old O2. After ensuring the oxygen's quality, it's released back into the Martian atmosphere. Each run of this process takes a few hours, but the results are worth the wait. In that time, MOXIE can generate up to 10 grams of breathable oxygen. Crunch the numbers, and you'll find that in about 20 minutes, it can produce enough air for an astronaut. Quite a feat, isn't it? But here's the real kicker. This isn't just about oxygen, it's about the future of Mars missions. If we can produce oxygen on Mars, it means less cargo to transport from Earth. Less weight, less cost, more room for other essentials. So, while we may not be packing our bags for a Mars vacation just yet, MOXIE is proving that it's entirely possible to make the red planet a little more blue. So, one small step for a rover, one giant leap for oxygen production on Mars. So how does MOXIE do what it does? It's all about the power of electrolysis. Electrolysis, in simple terms, is a process that uses electricity to break down compounds into their basic elements. In the case of MOXIE, it's using electrolysis to crack open carbon dioxide molecules, which Mars has in abundance. Imagine carbon dioxide as a tightly locked box. Electrolysis is like the key that unlocks this box. When we turn the key using an electric current, the box pops open, releasing the carbon and oxygen atoms trapped inside. But here's the thing. Carbon dioxide is made up of one carbon atom and 2 oxygen atoms. When we break it down, we end up with 1 carbon atom and 2 oxygen atoms. The carbon atom joins with another oxygen atom to form carbon monoxide, which MOXIE doesn't need. So, it gets discarded. That leaves us with 1 lonely oxygen atom. But wait, we can't breathe oxygen atoms. We need oxygen molecules, which are made up of 2 oxygen atoms. So, our lonely oxygen atom finds another lonely oxygen atom, and they join forces to create an oxygen molecule. Now, we can't just send this oxygen molecule out into the Martian air without checking it first. We need to make sure it's the good stuff. So, the oxygen molecule goes through a quality check. If it passes, it gets released back into the Martian air. This whole process takes a few hours, but it's worth the wait. In that time, MOXIE can produce up to 10 grams of breathable oxygen. That's enough air for an astronaut for about 20 minutes. And the best part? This isn't just a one-time thing. MOXIE has been doing this over and over again since it landed on Mars. It's like a little oxygen factory, tirelessly working to make the red planet a little more like home. And voila! Oxygen production on another planet. Now that's a breath of fresh air. Why does this matter, you might ask? Well, think about the future of Mars missions. MOXIE's ability to create oxygen from Martian air is a game-changing development that could revolutionize space travel as we know it. It's not just about the oxygen we breathe, but the entire logistical approach to future Mars missions. Consider this. The journey to Mars is a long one, taking anywhere from 6 to 9 months. During this time, astronauts need to carry everything they need with them: food, water, and crucially, oxygen. Every gram of cargo matters, and the need to carry oxygen has always been a significant challenge. But what if they didn't have to bring their entire oxygen supply with them? That's where MOXIE comes in. By producing oxygen on Mars, the need to transport vast amounts of it from Earth could be significantly reduced. This could lighten the spacecraft, making the journey to Mars more efficient and cost-effective. Plus, it could free up space for other essential supplies, or even allow for larger crews. But it's not just about the journey. Imagine the possibilities for human habitation on Mars. If we can create breathable air on the red planet, we are one step closer to making it a place where humans could live and work. Oxygen production could support the creation of habitats and even aid in the production of fuel for return missions to Earth. This breakthrough is about more than just survival. It's about expanding our horizons, reaching for the stars, and making what once seemed like science fiction into a tangible reality. It's about the dream of humans becoming a multi-planet species. And so, with every breath of oxygen Moxie creates, we inch closer to a future where Mars is more than just a distant red dot in our night sky. It becomes a potential new home, a new frontier for exploration, and a testament to human ingenuity. It's not just about breathing. It's about making Mars a viable option for human life. And we're not stopping at Moxie. No, indeed, the future of oxygen production on Mars is an exciting horizon that's already sparking new ideas. Scientists are brainstorming ways to scale up Moxie's system to maximize its potential. This could mean creating a larger oxygen